In this very lesson, we shall be looking at multiplication of matrices. Remember, we are still on the same topic, matrices. To begin today's lesson, we shall be looking at multiplication of matrices by a scalar factor. Given that A is a matrix and this matrix is a 2 by 2 matrix and K is a scalar factor where K is a number, then Ka means we want to multiply the scalar factor by the matrix. So in doing that, we are going to multiply all the entries in the matrix by the scalar factor. We have K multiply on all the entries in the matrix. So we are going to have K times A will give us what? Ka. K times B will give us what? Kb. K times C will give us what? Kc. And K times D will give us what? Kd. So multiplying a matrix by a scalar factor, what we do is to multiply all the entries by the scalar factors. We have K multiplying A, giving us Ka, K multiplying B, giving us what? Kb, K multiplying C, giving us Kc, and then K multiplying D, giving us what? Kd. So we have example. Let's look at how best we can apply this to solve this example. Given that P is a 2 by 2 matrix with these entries, you want to find 5P, half P, and then 2P, where 5 is a scalar factor, where half is a scalar factor, and 2 is a scalar factor. And as you know, P is our matrix. So let's look at the first one. We have 5P. It means we are going to multiply what? The matrix by the scalar factor, which is 5. So we are going to have 5 times 4 will give us what? To give us 20. 5 times minus 1 will give us minus 5. 5 times 2 will give us what? 10. 5 times 3 will give us what? 15. As easy as that. Multiplying the entries in the matrix by the scalar factor. Let's look at I. So we are going to have half multiplying 4, and then we have half multiplying minus 1. We have half multiplying 2, and then we have half multiplying what? 3. Let's continue from this side. Half times 4 will give us what? 2. Half times minus 1 will give us minus 1 over 2. Half times 2 will give us what? To give us 1. Half times 3 will give us what? 3 over 2. So let's look at another aspect under multiplication of matrices, and that is multiplying a matrix by another matrix. To find the product of two matrices, can you take note of this? The number of columns in the first matrix must be equal to the number of rows in the second matrix. Very, very, very important. So this is what I mean. So if you have a first matrix, let's say matrix A, and this matrix is a 3 by 2 matrix, and then you have another matrix, let's say matrix B, and this matrix B is also a 2 by 1 matrix. Since the number of columns in the first matrix is equal to the number of rows in the second matrix, then the product of these two matrices can be found. In other words, we can multiply these two matrices together because the number of columns in the first matrix is equal to the number of rows in the second matrix. Similarly, if you have, let's say, a 4 by 1 matrix, and then you have another matrix, a second matrix, which is, let's say, a 1 by 2 matrix, since the number of columns in the first matrix is equal to the number of rows in the second matrix, then these two matrices can be multiplied together. But if the number of columns in the first matrix is not equal to the number of rows in the second matrix, then these two matrices cannot be multiplied together. This is what I mean. If you have, let's say, a first matrix which is a 2 by 4 matrix, and then you have another matrix, a second matrix which is a 3 by 1 matrix, since the number of columns in the first matrix is not equal to the number of rows in the second matrix, then these two matrices cannot be multiplied together. Let me repeat it again. If the number of columns in the first matrix is not equal to the number of rows in the second matrix, then these two matrices can't be multiplied together. Kindly take note of this. The resulting matrix, when these two matrices are multiplied together, is going to be of this very form. So we are going to have a 3 by 1 matrix. So when these two matrices are multiplied together, the resulting matrix is going to be a 3 by 1 matrix. Similarly, when these two matrices are multiplied together, the resulting matrix is going to be a 4 by 2 matrix. Now that we know these few important things, let's see how we can multiply a matrix by another matrix. In multiplying a matrix by another matrix, this is what we are going to do. We are going to multiply the first row of the first matrix by the first column of the second matrix. To see it clearly, this is what we are going to use. We are going to multiply the first row of the first matrix by the first column of the second matrix. So it's like a magnet. This will multiply that. So we have A will multiply E, then we bring our addition sign, B will multiply G. Then we move on to the next column of the second matrix. But remember that this is a 2 by 2 matrix, and therefore we can multiply these two matrices together. This is a 2 by 2 matrix. This also was a 2 by 2 matrix. And since the number of columns in matrix A is equal to the number of rows in matrix B, these two matrices can be multiplied together. So we have this multiplying that. So we have A times U give us what? AE. AE. Then we bring our addition sign. B times G will give us what? BG. Now we are done with the first column. So let's claim that. Now once we are done, we are going to use the same rule for the first column to multiply the second column of the second matrix. So we are going to have A times F will give us what? AF. So we leave a space and then you have AF, and then plus B times A to give us what? BH. We are also done with this very part. Then after that, we are going to repeat the same approach for the second row of the first matrix. So we move on to the second row of the first matrix. So we are going to use this to multiply this. So we have C times U give us what? C plus D times D will give us what? DG. Now once we are done with this, we move on to the second column of the second matrix. So we have C times F will give us what? CF plus D times H will give us what? DH. So this is how we multiply a matrix by another matrix. So we have an example. Let's see how we can apply this in multiplying these two matrices together. So we have a matrix A which contains these entries, matrix B contains these entries. We want to find A, B. So we have AB. AB means matrix A multiplied by matrix B. So matrix A, we have these entries. And then matrix B, we have these entries as well. So we have our equal sign. So we are going to multiply the first row by the first column of the second matrix. 2 times 6 will give us what? 12. They will bring our addition sign. 1 times 5 will give us what? 5. Now we are done with the first column. Let's move on to the second column. 2 times 4 will give us what? 8. Plus 1 times 2 will give us what? 2. So we are done with the first row. We move on to the second row. So we are done with this. We move on to the second row of the first matrix. We are going to repeat the same cycle. 3 times 6 will give us what? 18. 2 times 5 will give us what? 10. Now we are done with the first column. Let's move on to the second column. 3 times 4 will give us what? 12. 2 times 2 will give us what? 4. Now let's add this together. 12 plus 5 will give us what? 17. 8 plus 2 will give us what? 10. This will give us what? 28. And this will give us what? 16. So this is how we multiply a matrix by another matrix. So the product of these two matrices is this particular matrix. So as I said earlier on, if you have, let's say, a 2 by 2 matrix multiplying by a 2 by 2 matrix, the resulting matrix is going to be what? A 2 by 2 matrix. So this is a 2 by 2 matrix. So let's look at the second one. So we want to find BA. BA means we are multiplying matrix B by A. So we are going to write matrix B first, BA. So matrix B must come first. So we have 6, 4, and then 5, 2. And then matrix A, we have 2, 1, 3, 2. The order of multiplying two matrices together plays a very key role. Don't mess this up. So we are going to multiply matrix B by matrix A. Okay, so we have this. We are going to multiply this by that. 6 times 2 give us what? 12. Plus 4 times 3 will give us what? 12. Good. So we are done with this. Let's move on to this. 6 times 1 will give us what? 6. 4 times 2 will give us what? 8. So we are done with this as well. And we are also done with this. So we move on to this. 5 times 2 will give us what? 10. 2 times 3 will give us what? 6. We are done with this as well. 5 times 1 will give us what? 5. 2 times 2 will give us what? 4. Now let's add them together. This will give us what? 24. This will give us what? 14. This will give us what? 16. And this will give us what? 9. Now let's compare the result from AB. This is AB. And then this is the result of BA. Are the results the same? Are these two matrices the same? We realize that these two matrices are not the same. So we can say that Multiplication of matrices is not commutative. Can you take note of this? Multiplication of a matrix, two matrices, is not commutative. That is why I said that the order of multiplying two matrices together plays a vital role or very important. Can you take note of this? This brings us to the end of today's lesson, but I'm going to give you 1 to 2 answer question. Try your hands on it, okay? So this is your 2 answer question. See you tomorrow. Bye bye.